Good morning, good afternoon, and good evening, everyone. Today, we're going to be talking about one of the sessions at Oracle CloudWorld on the AI track. And this is on how AI provided SailGP with real-time monitoring and predictive analytics. My name is Prasanna Venkatesan, and I'm Director of AI Product Management at Oracle. We are fortunate to have with us today Warren Jones, the CIO of SailGP, our customer as well. Warren?
Good afternoon, everybody. It's great to be here. We're really looking forward to talking about what SailGP and Oracle have with real-time monitoring and predictive analytics.
Fantastic. Thank you for that, Warren. Let's dive right in. I want to start with what our objective was when we first set out on this particular partnership with SailGP on utilizing AI for their operations. In short, the picture that you see here, this is the kind of scenario that we actually wanted to avoid. And in what you're seeing here today is actually the Team Great Britain boat. And in this particular scenario, they literally kind of nosedived straight into the water. And all this happened because one of the jib sails failed to release at the appropriate time. And this was something that kind of stuck with me as I started looking at how we could potentially work with SailGP in order to utilize AI in their operations. Now, SailGP has hundreds of sensors on each of their boats, and they work in particularly harsh environments. And we're going to hear from Warren more details about what exactly the race is about. And they needed to know when exactly it's happening so that they could change out the sensors. This could obviously lead to component failure. When you look at it, when we first started, we started with 27 sensors on 9 boats. And obviously, there are lots more of these particular sensors. And we needed to manage these data precisely, as out-of-the-box solutions would not fit this particularly sophisticated purpose. We had a lot of challenges in scaling across multiple sensors and components. We needed it to run much more efficiently. We needed to scale faster, and we needed much better ways of extracting all of these data that were coming in at a particularly fast rate out of the system. How fast? Let's take a look. Let me go on to the next slide here, and I'll play this particular animation for you. And this will give you an appreciation for why exactly this particular problem is so hard. So let's take a look at all the different subsystems that go into a SailGP boat, an F50 catamaran to be precise. So this is all the sensors, actually all the subsystems on a single boat. So as you can tell, even the subsystems are hard to read over here, and you can just multiply that by the number of sensors that are required to run each of these subsystems. And by the way, we're just looking at a single boat, and there are 9 boats in the race in season 3. So you can multiply that by 9, and the problem becomes fiendishly complex that a single human or multiple humans even cannot take a look at all the streaming data that's coming through. So this is a problem that's particularly hard to solve. So how did we exactly go about doing this? So let's move on to the next slide, how exactly we got started. So you can actually see here, this is actually giving you both the flow of data through the training process for the AI, as well as the flow of data for the inferences, so that once the models are actually generated, on how exactly you can pinpoint whether something is operating as it should or something has kind of gone off kilter and needs to be taken a look at. So, and in this particular case, you can see that the training data is coming in. And by the way, there are millions of data points that are gathered from each of these particular sensors over the course of a single day of events or a single day of racing. So we do a lot of timestamp pre-processing because this is extremely high frequency data. And we do a lot of normalization as well of the bounds to account for different sensor differences, or even within the same sensor, from different batches of sensors, they may have slightly small tolerances, and we didn't want to kind of go through the whole process of retraining. So we'll talk a little bit more about that. And we also did a data transformation to a rate of change. So we're not just looking at raw sensor values, but rather the rate of change of these particular sensor values. And again, Warren will be covering a little bit more on some of these sensor graphs, which will give you a little bit of an appreciation for that. And finally, once we actually filter this out, we normalize, clean it, and then we run it through the OCI AD service, or the Anomaly Detection service, where we sequentially train different models for all the different sensors that are mounted on a particular boat. This then gives us the trained models, which are then utilized during the actual event itself. And you can see that that is as far as the training flow goes. And then when we actually run the race, we get the test data from the boats again. And then again, we go through the same type of pre-processing and the differentiation with respect to the rate of change. And we use these models that we had from the training flow from the first step, and then run it through the anomaly detection service. And then finally, the anomaly detection service gives its raw output, which we then take through a consolidation logic so that we only look at the most important anomalies that are flagged by the system and fairly long-term anomalies as well, so that we are not actually overburdening the operations team with multiple things that they need to take a look at. And then finally, the output results are given to these human operators so that they can then decide what they need to do with it, whether they need to follow it up further or whether it is an anomaly that they can safely ignore for now. So this is the high level overview of how exactly this particular system worked for SailGP. And we came at this particular instance through multiple iterations between us and SailGP. So here is actually a short summary of how it's looking so far. 3 billion inferences is where we actually started with in May 2022 in Bermuda at the kickoff of season 3 for SailGP. And there were about 28 sensors for each single boat that we were actually monitoring. And of course, this was a small subsystem and not the entire gamut of sensors on each boat. Today, we are up to 7 billion inferences that are generated every single race event. And this was 7 billion inferences is what we actually generated at the latest race that SailGP ran in Andalusia in Spain. And today, from 28, we have gone up to 61 sensors that are continuously monitored with the Oracle AI Anomaly Detection service. So before I hand over to Warren, I just wanted to quickly show you all the different regions that Oracle has and why I think SailGP chose Oracle. So you can see that this is on a map of the globe. There are 39 different regions. 5 more are actually planned. You can see that we have Oracle OCI regions across pretty much every continent on the planet, save Antarctica. And if I overlay that on all of the SailGP race locations, you can see that there is almost a one-to-one mapping between where there are Oracle OCI regions and where SailGP actually conducts its races. And there's probably a little bit of room for more. So anyway, with that, I will hand it over to Warren Jones, the CIO of SailGP, so that you can hear directly from the source on how exactly they're using AI and what's in store for the future. Over to you, Warren.
Oh, thank you very much. We're at SailGP, we're immensely proud to be working with Oracle on these groundbreaking techniques. We are a global championships that we have events around the world. In season 3, we have 11 events around the world, as you've shown in the correlation between OCI data centers and SailGP events. From that point of view, we have 9 global teams racing against each other within the championship. And from that, then we race 3 races on one day and then 2 races on another day. Then the accumulation of all the points, then the top 3 then will race against each other to have the Grand Prix champion of that weekend. So it's 11 races this year, a lot of traveling around and a lot of huge amounts of data from the F-50s. We have a short video to explain what SailGP is. I'd like everybody to see it.
What is SailGP? It's high speed, high tech, high impact. 11 global events and an intense battle with 9 nations. Identical F-50 driven by the world's best. And powered by nature. Competing on a level playing field where both data is shared and talent actually matters.
Australia, they've got to keep clear of New Zealand.
It's close to shore racing in front of sellout crowds.
What a ridiculous animal!
Join SailGP in the race for the future, because our race is your race.
As you can tell, things move pretty rapid in the system. Find an anomaly by human observation is almost impossible. We mentioned earlier that one sensor alone outputs around 7 million data points every single sailing session. In order not to flag every small variation as an anomaly and throw up a lot of false positives, the system was designed with coalition logic that analyzes a rolling window of detected AI anomalies and only flags for human intervention if a threshold is exceeded. This data is from the Team USA F50, and the top picture shows the raw anomalies marked on the graph with a green overlay on top of a blue signal line. The bottom picture shows the same signal with the consolidated logic applied. As you can tell, there were no anomalies that were flagged from the human to take a look at. Now let's look at another team's boat. So this is the exact same sensor, but on the Team France SailGP F50. As you can see, the graph with anomaly output from the anomaly detection service has just lit up the entire chart. Even with the consolidated logic at the bottom of the chart, it's very obvious that there is something wrong with this sensor. Sure enough, there was, and it was replaced by the SailGP electronics team. We were lucky enough to have this used by the AI and AD service throughout, as we caught this during the training camp and not the Grand Prix itself, which would have been catastrophic from the team's chances. Despite the system failures, Team France actually placed second in 2 of the 5 fleet races, which was impressive indeed. So you can see how integrated using the consolidated logic is not to wear out the human operation team with potentially bad results. And the next picture shows why this is important. This is the Oracle Insights container as it's built inside a 40-foot shipping container that's easily transported around across the globe for all our races. Here's where we analyze all the data coming from the boat and we source everything from that point of view. It's also where we look at all the data from a systems point of view, and we look at the data is correct for the sailing teams as well. At SailGP, we do things a little bit different with the data. We have the ability for all the teams to access each other's data. So Team Australia can see Team France's information, Team France can see Team Britain's information. This is not general in any other sport in the federation, and it's quite unique to what we do. The teams will just access the Oracle cloud infrastructure, and from that point of view, then they have the ability to see all the data from that. So we house all our teams within this container. Then we have all our teams then looking at the data from the anomaly detection. We have around 5 people looking at that information. Usually 3 people would be in that container, and then there are 2 other people would be around the world. For instance, for the Andalusian Grand Prix that we had a couple of weeks back, we had 1 person in Australia looking at it and 1 person in the UK looking at the data from that in real time from that point of view as well. We tested different windows and different metrics before landing on one of the services that we struck the right balance, and continue to refine the processes and more with sensors through the AI Anomaly Detection service. We have Alex Reed is our head of systems, whose team is in charge of generating huge amounts of data on the boats. So they manage the anomaly detection. They also manage the data coming from the boats. We generate around 48 billion data requests every sailing session with all 9. And Alex has a couple of words that he'd like to talk about.
SailGP and Oracle have been working on something called anomaly detection. Anomaly detection is all about machine learning. It uses very kind of cutting edge techniques to find failed sensors or other issues on the F50. The anomaly detection looks at patterns in the data. What it really allows us to do is to expand our capabilities for finding these faults. On the F50 we have around about 125 sensors per boat, 9 boats and 1 billion data points per day per boat. So we need to apply much better techniques, which is where we ended up with the anomaly detection. The system will scan through all the data overnight and we'll get a report. It will highlight any anomalies that have come up. So with the anomaly detection, we've detected a failed pressure sensor. In an extreme case, it could be catastrophic failure. The anomaly detection certainly has helped us protect equipment and allow us to catch those issues before they happen. Yeah, so if the system did fail, you'd basically lose control of the hydraulics and the boat would effectively stop.
In this case, we found an anomaly with the pressure being random relative to the volumes. If you sort of have an anomaly that goes way out of parameter, you start starving your pumps from oil flow. You have side effects of that side of things, and then obviously damage sort of perpetuates from there. You know, picking up all these parameters, you know, often we get flagged with potential issues before they even affect the sailing or affect the boat. We start seeing some anomalies, and we can start diagnosing what's happening and start understanding what's happening way before it often fails. It gives us often a head start on what we're trying to maintain and what we're trying to keep up with speeds.
Typically the components are on the F50 are not off the shelf. They're designed in-house and manufactured in-house. Once we build models of those parts, it gives us an idea of the lifespan of them. It allows us to schedule servicing, keeping the boats running as efficiently as possible, and avoid any breakdowns on the race course. The anomaly detection basically allows us to have a series of virtual engineers constantly scanning through the data. It's something we could never do in day-to-day operation, but it's there constantly in the background. From Chicago onwards, we've basically thrown open the net to incorporate many more sensors on the boat. I think 20 times as many sensors as we had in Bermuda, and no doubt we're going to encounter more and more early issues.
Thank you, Alex. So SailGP, with the anomaly detection, we also have a lot of other things that we do with Oracle. One of the big things that we do is that we use Oracle Cloud for all our services. That includes our boat to database is around 100 milliseconds. And to achieve that, we use Oracle Stream Analytics and Oracle Cloud Analytics. From that point of view, then we create around 1,000 metrics or patterns within the Stream Analytics. And from that, then we send to our broadcast, our 2D graphics, our live line graphics that appear on our augmented reality on our broadcast, our SailGP app, and also our SailGP Insights powered by Oracle. From that point of view, we use all this information, all the data, all the metrics from speed, from distance between boats, how they go over the ley lines, and where they are from that point of view. From our electronics team, we can measure where each boat is from 1 centimeter on the race course. And from that, then we be able to look at that data and then send that data back to our Oracle data center and then create those metrics for our output for our SailGP fans to look at from that point of view. We also use from Stream Analytics, and we use our Cloud Analytics. We use the Cloud Analytics for the teams to go and look into the data. As I previously mentioned, the data is accessible by all the teams. So from Team Canada, who started in this in season 3 of SailGP, they never sailed an F50 before, and to sail an F50 is extremely difficult. They use the data from looking at the other team's information, and they use that to get to the point of where they are. And in the first race of season 3 in Bermuda Sail Grand Prix, they were lucky enough to win a race, which they credited that looking at the data from Oracle helped them to get into the position of where they could have won a race on their first go, which is pretty amazing from that point of view. We're also looking at a cloud simulator for SailGP. We travel the world a huge amount, and to get a boat on the water is a huge amount of time, effort, and people to do that. And the athletes need more time on the boats to perfect their art. And that from that point of view, we're looking to produce a cloud simulator with Oracle. So we've been building this for the last 18 months. And from that point of view, we'll be able to pit our teams against each other in different locations around the world using the power of the OCI and Oracle cloud infrastructure from that point of view. The teams want to practice, and they want to practice their starts. They want to practice their mark roundings. So from that point of view, we have an ability to do 100 starts with the skipper of the US team, Jimmy Spittle, against the skipper of the British team, Sir Ben Ainsley, having the ability for them to compete against each other when they're in their own countries is something remarkable from our point of view. So to have Oracle help us do that is truly breathtaking from that perspective.
Fantastic. I think that was a fantastic overview, Warren, and thank you for that. And we are really looking forward to expanding this partnership further with SailGP and into the future, as you had mentioned. So for those of you who are able to join us in Las Vegas, please do come and hear a much more expanded version of what we covered today, including some of the engineering challenges that we'll be going into as we solve the many different curveballs that SailGP threw at us as a very sophisticated customer. The session with Warren is going to be on Tuesday, 18th October at 12:15 p.m. in Las Vegas, Nevada. And Warren will also be joining Elad Ziklik, the VP of AI, at his keynote as an invited guest, where he has some surprises planned as well. So we really look forward to having you join us at CloudWorld 2022 in Las Vegas. See you there.